next, I'd like to introduce Hallee Shearer from Northeastern University, who will talk to us about BrainEffex, an interactive web application for exploring typical fMRI effect size estimates. Thank you.
Sorry, just one sec. I'm just going to find it here. I'm impressed by how quickly everyone else pulled up their slides. There we go. Okay. Hello, everyone. My name is Hallee, and I am at Northeastern University with Stephanie Noble. And today I'm going to tell you about our tool called BrainEffex for exploring typical fMRI effect sizes. I don't have any disclosures. So over the last decade, the topic of reproducibility has been in the spotlight in many fields, including our lovely field of neuroimaging. And one of the ways that we can improve the reproducibility of our research is by conducting power analyses during the study planning phase. To do this, we need a few key ingredients. We need to set the target significance level and power level, and these will represent how comfortable we are with the possibility of obtaining false positives or false negatives in our study. Then we need to know an effect size that we want to power ourselves to detect. And with these, we can calculate the sample size required to be powered to detect an effect of that size. Just going to check if my pointer works here as well. Do you see that? No, you don't. There we go. Laser pointer. Okay. So, sorry for the interruption. Okay. The question is, how do we determine the effect size to put in this calculation? For fMRI specifically, this can be really tricky. We need to choose an effect size that is meaningful, but how big of a difference in bold activation or functional connectivity is meaningful? How big of effects do we expect in fMRI? We could try to check the literature, but many studies don't report effect sizes, and if they do, they often don't report them across the whole brain. So this is where BrainEffex comes in, as a place to explore these effect sizes that we can expect in fMRI. Before I show you the app, I'm going to walk you through the data that we used and our analysis pipeline. Then I'll show you the app and then tell you a bit about the technical side of app development and how you can contribute to the app if you would like. So starting with the data, sorry, now my mouse is stuck as a laser pointer. Sorry. Going to turn that off. No, I'm not. Okay. I'll be in laser pointer mode. So starting with the data. To create BrainEffex, we leverage the fact that large sample sizes can help us get precise estimates of effect size. Luckily, we're in a field with an abundance of large publicly available data sets, as we've talked about a little bit already. So we took 6 of these data sets and ran 58 different tests, which we refer to as studies here, and I'll talk about those a bit more in a second. The height of each of these colored bars represents the proportion of those 58 studies that fall into each category. So for example, most of these studies came from the ABCD data set and not as many from the Healthy Brain Network. Moving from left to right here, we can see that all the studies have a sample size of at least 400. Some have upwards of 1,000, and from the UK Biobank, we have over 35,000 subjects. The vast majority of these studies use functional connectivity maps, but we do have a handful that use activation maps. And with this data, we ran a bunch of typical fMRI analyses. And by typical, I mean we ran 1 sample t-tests, 2 sample t-tests, and brain behavior correlations, depending on the type of the data that we had. For example, if you provide us with every subject's age, then we can do a brain behavior correlation between the brain data and the age. And that would count as 1 study here. And these 58 studies cover a range of categories, including psychiatric, cognitive, biometric, and age. So for each of those tests or studies, we ran every combination of the following pooling and motion parameters. For pooling, we ran each test at the univariate voxel or edge level and at the network level after pooling, and we also ran a multivariate version of the test. And for motion correction, we either thresholded or regressed out frame-wise displacement or did no motion correction. So for every one of those studies then, we ran the test with every combination of motion and pooling parameters to get the group level statistical maps. We converted those statistical maps into two different effect size estimates, Cohen's d and r squared, and we also computed simultaneous confidence intervals around each estimate. Then with this data, we ran a script to generate visualizations of the effect maps and then fed those figures into the app. Which brings us to the app. Here it is. This is a simplified version of it. So if you go to the app, in the middle you'll see a bunch of plots, one for each of the studies that we have. And these are showing the effect sizes from our analyses. The plots show the effect sizes of all voxels or edges sorted by increasing effect size from left to right. And the shaded area represents the simultaneous confidence intervals. They are red if they overlap with 0, which is this dotted line, or they're green if they don't overlap with 0. And below the plot, you can find more information, including the multivariate effect size there. The next plots help you see where those large or small effect sizes lie spatially, which parts of the brain have larger or smaller effect sizes. These are plotted on the brain for activation map studies and illustrated as matrices for the FC studies. And the section on the left-hand side provides options for filtering these these studies. So when you first go to the app, you would see all 58 studies, but if there's only certain things you're interested in, you can filter the data by data set, by map type, task, etc. And then the bottom options here let you select how you want motion to be regressed out or not regressed out, and how you want the data pooled, and which effect size measure you want to see. We also conducted meta-analyses for each test type and for the different categories of studies, like biometric, cognitive, and psychiatric, and you can find those on this meta-analysis tab. So now thinking back to our goal of performing a power calculation, how do we take this information and find an effect size? There's more details in our preprint, but basically it depends on how you want to power your study. For example, if you're interested in a particular region or a network, you could power the study to detect that effect, or you can choose to power yourself to detect the multivariate effect size if that better suits your research question. With any of these options, you can choose to be extra conservative and power yourself to detect the lower bound of the confidence interval, or be more liberal and use the point estimate. And with that information, you can then use a tool like G-Power or R's power calculator to perform the calculation. So now I'm going to give you a bit of insight into the app development for anyone who might be interested. We used a R package called Shiny to build the app, and a Shiny app consists in its most basic form of a user interface script and a server script. The user interface script dictates how the app should look, and the server script dictates how it should behave. So for example, in the user interface script, we can code that we want a button there called reset filters, and then in the server script, we code what should happen when someone clicks that button to reset the filters. Now, BrainEffex is intended to be a growing resource. That being said, we really welcome, I'm not sure why that's not showing up there. That's supposed to say subject level data sets of 500 or more subjects instead of all of those little boxes. So yeah, we're welcoming data set contributions that have more than 500 subjects at the subject level, so either functional connectivity or activation maps for each subject. We have a section of our preprint that's dedicated to how you would contribute that data if you're interested. But in short, what we need is some information about the study, the data set, we need the brain data, and some sort of an outcome variable. So for example, if you provide us with every subject's age, then we could do a brain behavior correlation with that. Or if you give us more than one outcome variable, then we could create multiple studies to put from your data set. And you would just upload that data to BrainLife which is the subject level data. Then we can run it through our pipeline to generate the effect maps and the visualizations, and then feed those into the app. So that's BrainEffex, our tool for exploring fMRI effect sizes. We hope that it'll facilitate study planning and improve the reproducibility of our research. Please note that it is a growing resource and we're still working on it. So that means that it might not have exactly what you're looking for right now, but we're hoping to cover more ground as we get more data, and also looking to add more features. So if anyone has recommendations or ideas, please come talk to me. Also, please keep in mind that while it's not a power calculator in its current form, we are working on developing that, and this provides a basis for empirical power calculator. With that, I'd like to acknowledge that this was a big group effort, so thanks to all of our collaborators, my lab, and my brilliant supervisor, Dr. Noble. And I'll leave the QR code there if anyone has questions.
Thank you. Please post some questions for Hallee on the app. Any question on the microphone? Thank you.
Oh, yes, this is fantastic. Thank you very much. Did you identify parameters like maybe the amount of smoothing or the type of traits that actually influences effect sizes, or what would be your recommendation? What should we do to have the maximum effect size?
That's a great question. We do have another paper coming out. This is more about the tool, but we have another paper coming out about the results of this, so what we actually found in terms of trends for the effect sizes. And that Steph has been working on more than me, so I don't remember the exact findings, but the brain behavior correlations have the smallest effect sizes, as we've seen in other things as well. But in terms of the motion, I don't want to tell you anything that's false, but if you play around with any of those parameters in the app, you'll be able to see the effect sizes change. But also keep your eye out for that paper, which will have those results and discuss them more.
There is a question from the app asking you whether you had considered including the impact of test-retest reliability on the observed effects.
That's a good question. I love test-retest reliability. That's what my other research is on. But I'm not sure. I'd be interested in more information about that idea of how we would incorporate that, because we would need test-retest scans. And for some of this data, we might have it, but probably for smaller sample sizes. I don't know of many studies that have test-retest scans for a large enough sample size to include here. But if you know of some, come find me and tell me more about that.
Yes, absolutely. Okay, thank you, Hallee.
Thanks.